Okay, so this last section is applications of vectors. The first thing we're going to talk about is just these definitions at the beginning. Just something to keep in mind. Your final answer for displacement should always be a vector quantity since it has direction and magnitude, but distance will be a scalar. It's just a number because it's the magnitude of the displacement. Velocity is a vector quantity. Speed is a scalar. So just keep in mind that speed is just the magnitude of velocity. Acceleration is a vector, but sometimes we use it as a scalar. So you just need to be careful with the context of the problem, just making sure whether or not it's looking for just the number or the direction as well. Okay, so here are some example problems. Most of them are going to have to do with physics. So I'm just gonna jump right into it. The question reads, on a sunny day, two sailing boats, Rab and Peg, were spotted from a lighthouse. The courses of the boat are given by these equations. All the units are in kilometers and the parameters, that's the T, represent time in hours. So question A wants us to find the position of the boats when they were spotted and the distance between them. So when they were spotted, that word I see in the first sentence, it's the courses from the moment they are spotted, meaning that the moment they're spotted is where time is 0. So for part A, I'm going to set t equal to 0 and s equal to 0. Then you should get the points. Hopefully I can write on this without disconnecting my charger. So when I say that t equals 0 and s equals 0, the 2 points that you should get are -1, 10 and 0, 4. When you plug those into the two equations that they give you, these are the 2 points. And then you're just going to use the distance formula, which is something that you should know how to do by now. And once you do, you should come up with 6.08 kilometers. That's the distance between them. So that's part A. Part B says to calculate the speed of each sailboat. So in order to do that, remember that speed is the magnitude of velocity. So we're going to take our direction portion. So we have 2i minus 2j for the first one. I get that from the pieces with the t. So 2i minus 2j. And for the second one, we have 2i plus 3j. So 2i minus 2j and 2i plus 3j. Okay, and then we're going to take the magnitude of each of these. And you should end up getting, for the first speed, 2.83 kilometers per hour. And for the second one, it is 3.61 kilometers per hour. So that's part B. Part C, find the coordinates where the courses meet, meaning I want the time where their positions are equal. So that means just setting the two equal to each other and solving the system. So I would have -1 plus 2t is going to be equal to 2s. Those are my I components. And then now I set my j components equal to each other. So I have 10 minus 2t equals 4 plus 3s. Okay, from there, it is pretty simple to see that the t's can be eliminated. So when I'm solving this system, I get 9 equals 4 plus 5s. So then you should get that s equals 1 hour. And then you plug it back in and you get that t is equal to 3/2 hour. Either one of those 2 points that you plug in, your final answer of the coordinates where they should meet is 2, 7 when you plug it back into those original equations. Okay, from there, Part D, explain whether or not the boats will collide. Based off of the fact where they collide and the times were different. So the points where the paths would have intersected was at 2:07, but the time for the first one was at 1 hour and the other one was for an hour and a half. So since the time is different, they will not collide. Okay, moving on to our next example. I still need to put the picture in here for y'all, but it will be on your notes. But basically, the first one says to find at what angle the route Luca should swim to get directly to Preco, and give your answer in 3 significant figures. So here, let me pause and just put the picture in here now so you can see it. So here is the picture of these two cities across the canal. So he has his average speed in a pool, but that is not including the sea current, which runs perpendicular to the route and has a speed of 1.2. So basically what helps me is this picture would be crooked if I were to connect them. But basically you can create a, what's it called? Parallelogram. So here is my plane. We have in green 1.2, and in red we have 1.8. Okay, so based off of this information, it wants me to find the angle that he should swim at to travel directly to Preco, or Preco. I'm uncultured, I couldn't tell you. So you do sine of theta is equal to 1.2 over 1.8. We're just finding this angle up here. And so once you do, you should get that the angle is 41.8 degrees. So that's part A. Part B says determine how long it will take to travel the length of the route if it's 4.5 kilometers. So just remember that time is equal to distance over velocity. So we end up getting that the time is equal to, this one's important. It's 4.5 kilometers, but since the speeds are in meters per second, you have to convert to meters. So here is that increment in meters, 4,500 over velocity, which is magnitude. So we have the square root of 1.8 squared minus 1.2 squared. And that should come out to 3,354 seconds, which I believe IB would accept. But for me, I would put that into a more reasonable answer and do a conversion. So I would convert to minutes and seconds. So that is 55 minutes and 54 seconds when you break that down. Okay. From there, we have drones. This is kind of similar, I think, to the other problem. The first step is to find the speed of each drone, which is just to take the magnitude of the direction. So for the first one, it would be the magnitude of 234. And for the second one would be negative 247. We're getting those numbers here and here, the things with the parameter. So once we take the magnitude, we end up getting sorry, iPad keeps on coming up, not unplugged. For the first one, you should end up getting 5.39 meters per second. And for the second one, you should get 8.31 meters per second. Okay, so that's part A. Part B, determine the distance between the two drones just before Ida's drone starts. Well, it does say that after 3 seconds is where Ida's drone starts. So for Ida's, we would have a time of 0, so S would be 0. But that means that Irma's would be at 3. So T equal to 3. Those are the values that you plug in. The points you should end up getting are -4, 6, and 12 for Irma. And for Ida, you get -4 to 0. Now, what you should do here is plug those into your distance formula to find the distance between them at these 2 points. And you should get 12.6 meters. All right, moving forward, it tells you that the drones will collide, and then figuring out how long Irma's drone was flying when they do collide. Okay, so what we do is we just solve the system. So you're going to set the pieces with the i's together. So it would be 2 minus 2t equals -4 minus 2s. So -4i minus 2si. So then we set them equal to each other. And then you proceed with the same concept. So your next line of the system would be -3 plus 3t equals 2 plus 4s. And 4t equals 7s. I think it's easiest to solve for s. So here you would get that s is equal to 4/7 t. And once you have that, you can plug it up into the above equations to figure out what those values come out to be. You should end up getting as a final answer that t is equal to 7 and s is equal to 4. But they want to know the time that Irma's drone. And so the Irma's is the first one, and the parameter that goes along with Irma is t. So my final answer is t equals 7. Okay, lastly, it says find the altitude where they collide. So you could plug in either of these values to their corresponding equations, and you should get the same answer. And that answer is you should get the point -12, 18, 28 for whichever one you plug in. But once you get this point, the altitude would be the z coordinate. So the altitude, our final answer is 28 meters. Okay, last but not least, we have forces, which I know you guys loved. So the first one is Hannah's weight. Most of you should remember that weight is the magnitude. So it's the mass times magnitude of gravity. Or absolute value of gravity. Sorry, goodness gracious. So in this case, the force acting would be, when you plug in her mass of 30 kilograms, you should get 294.3 newtons. So that is part A. Part B, it helps, I think, if you go ahead and draw out the picture. So I'm going to draw that picture first. And so we have our slope. And we have Hannah here. So her weight is here, W. And then we have the normal. And we have, here is P, which corresponds with this P. This should be R for the perpendicular. And then this way is T, which is our traction. You don't need all of those things yet, but this is just for now. And there's a little angle here. This angle should match this angle. which will help us set up some of our equations. So N is the perpendicular projection of W to the normal to the slope. So the normal to the slope is R, and then the perpendicular projection. So we have this should be the same thing as this, which is the same thing as W cosine of 35. And we get that from right here where we have this angle and then N is next to it adjacent, meaning we need to use cosine. I don't know why that's scooted over, but this is 35. Okay, so once you plug that in, that magnitude of the reaction of the slope on her weight would be 241 newtons. And then from there, we follow the same premise for her speed from resting to 50 miles per hour. It starts the same way. The first step is to figure out what P is, which would be her moving down the slope. And so in order to do that, maybe I should keep the picture up. In order to find P, we have 2P magnitude W. And in this case, it would be the sine because it is opposite. This P down here is opposite of the angle. So we have sine 35 degrees, which should come out to 169. Okay, so then the next piece of information that we have is that magnitude of her distance is going to be P minus T. And we know that P in this case we just found was 169, and they tell us the traction of 80 newtons. So then it comes out to be the force is 89 newtons, a net of 89 newtons. And then we know that acceleration, I'm running out of room. Then we have that acceleration is here. Divided by her mass. So we have 89, which is the answer that we just found, over 30. Which comes out to 2.96 meters per second squared. So that's her acceleration. But then we know that her initial velocity is 0 because she's at rest. But then the velocity squared is equal to 2 times the acceleration. So then we have times her distance, and then that when you plug it in and solve it, you should have taking the square root of 2 times her acceleration of 2.96 times the distance of 50 meters. So once you take that, then you should end up getting 17.2 meters per second. Okay, so that was part C. Part D says the maximum angle of the slope so that Hannah will not slide at all. In order for Hannah to not slide, that means that we need the force parallel to the slope has to be opposite to T. Like it has to be the traction, they have to balance each other out if she's not going to move. So that means that we need the force parallel to the slope to be equal to 80, the traction. So then if you solve that out, you should get that theta is equal to the sine inverse of 80 divided by, and we know her weight from part A being 294.3 newtons, which then should come out to 15.8 degrees. That would be the maximum so that she wouldn't slide. Great. There are extra practice problems available, and I will also be posting your review for you as well.